Okay, so we have discussed that a centralized DNS has several problems. We have discussed that a centralized DNS have several problems, so we should have a distributed DNS. Okay, so by distributed DNS, what do you mean? That instead of single DNS, we may have multiple DNS servers that are distributed geographically over different areas. For example, what DNS server is placed here, another is placed here, another is placed here, another is placed here, another is placed here. Okay, so now the question arises that how these distributed DNS are connected with each other, and how the DNS record they are distributed over these DNS servers. Okay, so this is a question, and this question has been addressed in the current internet as follows. So in the current internet, this hierarchy is used to arrange the DNS servers. So in this hierarchy, there is some root DNS servers. These are called root DNS servers. And the root DNS servers, they are connected with the top level domain DNS servers. Top level domains. Like for example, .com. Those URLs that ends with the some like for example .com, .net, .org, .edu, even .pk, .france. So these top level domains they are called top level. So there are some root DNS servers, and the root DNS servers they are connected with the top level domain, and these top level domain they are connected with the sub DNS servers. For example, yahoo.com. So yahoo.com is connected with the .com. Amazon.com, so they are connected with Amazon. Similarly, for example, google.com, so Google will be connected with the .com. So all the DNS servers that ends with .com, they are connected with the .com. Similarly, those DNS servers that end with the .org, so they are connected with the .org, and so on. So what does it mean? For example, so they are arranged in this order. Okay, so whenever a client wants an IP for a name, for example www.amazon.com, so the client will first go to root. It will go to root. So the root DNS, it will go to root DNS that the client needs the IP address of www.amazon.com. If the root doesn't have the IP address of www.amazon.com, then it will examine the name. So the name it contains .com. So the root will forward this query to .com. And when the .com receives this query that client needs the IP address of www.amazon.com, and .com also doesn't have the IP address of www.amazon.com, so it knows that it can be found with the amazon.com, so it forwards this query to amazon.com. The root DNS server, it forwards with .com. Why? Because the name ends with .com. So all the host name that ends with .com, they are attached with the .com DNS server. So therefore the root DNS it forwards to .com DNS server, because the .com DNS server it has the information of all the host name that ends with the .com. Similarly, the .com knows that it is amazon.com, so the amazon.com is attached with the .com DNS, so it forwards to amazon.com. So the amazon.com it will have the IP address of www.amazon.com. So amazon.com will forward it to the response to the .com, and the .com will store the IP address of Amazon.com in its cache, and then it forwards to root. The response is forwarded to root, and the root also stores one copy of the IP address of www.amazon.com, and then the root forwards that response to the client. Okay, so this is a one way that is this hierarchy is traversed. So if the client wants to access IP address of www.amazon.com, so the client requests a root server to find .com DNS server, and then the client queries .com DNS server to get. Then since the root doesn't know about the IP address, okay, so it forwards to .com. Okay, so if the root DNS server, it doesn't have the IP address of Amazon.com, www.amazon.com, so it will forward the client request to .com, and then the client.com, it doesn't have the IP address of Amazon.com, so it will forward to Amazon.com DNS server. And this has the IP address of www.amazon.com. If it doesn't have, then it will respond that this name doesn't exist. So the client queries Amazon.com DNS server to get the IP address. Okay, this is the one way. Okay. Now, who are the DNS servers? Who are the DNS servers? Who are the root DNS servers? So, in the current internet, the root DNS servers, they are 13 root DNS servers, and they are worldwide distributed, and they are known. Okay, so they can be contacted by a local name server, or it can be contacted by a client. We will discuss what is the local name server. Okay, so the root name server, it contacts authoritative name server if name mapping not known. So it means that if the root, so the client, they always contact root DNS servers, and these root DNS servers, they are 13, and they are known. So if the root DNS server, it doesn't know, so then it contacts the next level DNS servers. They forward the query or contacts the next level DNS servers, and if they doesn't know, then it forwards to further next level. But okay, so they are arranged in this hierarchy. Okay, so the first is the root level DNS server. So we have discussed that there are 13 root name servers available worldwide. Okay, next is top level domain. Top level domain is called this one. This is called top level domain, and these top level domain are, for example, for .com, .org, .edu, .net, etc. These are the top level domain servers. Okay, so the top level domain, they are responsible for .com, .org, .net, .edu, etc. These are all top level, and there are also top level domain like, for example, .uk for UK, .fr for France, .ca for Canada, .jp for Japan, similarly .pk for Pakistan. So the network solution, they maintain servers for .com. Similarly, Educase, it maintains the edu top level domain. So each domain server, it is maintained by a particular provider, and they charge it for it. We will discuss it. Okay. Similarly, the organization's DNS server, they are called authoritative DNS servers, where the original IP address and name is stored. That is called authoritative DNS. Okay, so it provides the authoritative host name to IP address for organization server, like, for example, web server or mail server. And the authoritative DNS servers, they are maintained by an organization or by a service providers. Okay, so this is the hierarchy we have discussed. Okay, Now there is a local name server. The local name server, it doesn't belong to DNS hierarchy. You know that in this DNS hierarchy there is no mention of local name server. This is the DNS hierarchy. Okay, so in this DNS hierarchy there is no local name server. So it is not necessary to have a local name server. It is not mandatory. Okay, so how it is used, let's discuss it. Each ISP or each enterprise network is a residential ISP or a company or university, there has one local name server, and this is also the default name server, and you can even run your local name server in your hostel, in your home, in your dorm. What is the use of local name server? Local name server, it acts as a proxy, as we have discussed web cache proxy server, if you do remember. So the local name server, it is also acting as a proxy, but for what? It is acting proxy for the DNS query. Okay, how it works, let's discuss it. First of all, suppose in a university, this is a ComStats university. In the ComStats university, this is the client, this is the local DNS server in ComStats university, and this is the DNS hierarchy. Okay, suppose the this user, it wants the IP address of cis.pulley.edu. So what it will do? It will forward the query to its local DNS server. Okay. If the local DNS server, it doesn't have the IP address of cis.pulley.edu, then it contacts the root DNS server. It contacts the root DNS server. This one. Now the root DNS server, suppose it also doesn't have the IP address of cis.pulley.edu, but it knows it doesn't have, if the root DNS server, it doesn't have the IP address of cis.pulley.edu, but it notes that this name, it ends with .edu. So the root DNS knows that for edu, this top level domain is responsible. Why? Because we have discussed that in the DNS hierarchy, the root level DNS, they knows all top level domain. Okay, so therefore the root DNS, it knows that for .edu, because this host name, it ends with the .edu, so the top level domain for the edu is this one. So there are two ways. One way is called iterative query. From root level DNS to resolve the name server in the hierarchy, there are two ways. One is called iterative query. Iterative query, what does it mean? That the root level, it doesn't have the IP address of cis.pulley.edu, but the root DNS knows that this name ends with .edu. So the edu DNS knows the IP address of this. Okay. So therefore the root level DNS in the iterative query, it returns to the local DNS server that I don't know the IP address of cis.pulley.edu, but you should contact this top level domain .edu DNS, it may knows. Okay. So the root level DNS, it returns what? It returns response to the local DNS server that I don't know the IP address of cis.pulley.edu, but you can context this top level domain DNS. Okay. So then the local DNS contexts this top level domain. It contexts the top level domain and it asks that what is the IP address of cis.edu, cis.pulley.edu. Since this DNS server, it also doesn't know the IP address of this, but it knows that this IP address has the second dot pulley. So it is the pulley DNS may knows. This CS domain may knows because this is already maintained. We will discuss later in this video, that in this class, that how the record is inserted. So therefore the top level domain knows that I don't have the cis.pulley.edu address, but it can be found with this DNS server. So therefore the top level domain in the iterative query, the top level domain DNS server returns the response to the local DNS that I don't know the IP address, but you can contact this DNS server for its IP address. Okay, so the local DNS server then contacts this DNS server dns.cs.umas.edu, and this DNS server, it stores the IP address of cis.edu.pulley. So this one is called authoritative because it is stored here. This is called authoritative DNS server. So this will returns the IP address. So when the local DNS server, it gets the IP address, then this local DNS server returns the IP address of cis.pulley.edu to the requesting host. So this way is called iterative query resolve from the root to the authoritative. This is called iterative query. So this is one way of finding the IP address of cis.pulley.edu or of any host name in the root DNS, in the DNS hierarchy. This way of finding the host name, the IP address of a host name, is called iterative. Why? I don't know this name. For example, the root DNS, when it receives the query, so the root say, I don't know this name, I don't know the IP address of this name, but ask the top level domain dns.edu. It may knows. It may know. Okay. So this is called iterative query. This is called iterative query resolving method in through DNS hierarchy. So what is its advantage? What is its advantage? Its advantage is that, for example, suppose the host asks for cui.edu. What will happen? The host will send the query to local DNS this way. Now the local DNS doesn't know the IP address of cui.edu, but this host name, it ends with the .edu. So the local server also knows that for edu, that all names that ends with edu, this is the top level domain. Because when this query cis.pulley.edu was resolved, so when this local server, it contacted the root DNS, so the root DNS returned the response that I don't know this name cis.pulley.edu, but you can contact this top level domain for edu, for all host name that ends with the edu. So this local DNS caches that information, that for .edu the top level domain is this one. So when this query for cui.edu is received at the local DNS, so the local DNS directly contacts the edu server. It contacts the local top level domain. So this is skipped up. So what will its advantage? The delay will be reduced. The delay is reduced. This step is skipped, so the time is saved. So this is its advantage. Okay, now there is another way of resolving the DNS name in the DNS hierarchy. This is called recursive query. And what does recursive query means? For example, this is the host. It wants to get the IP address of cis.poly.edu. So in the first step, it will contact local DNS. Now if the local DNS doesn't know the IP address of cis.poly.edu, so in the second step, it will ask root DNS. Now the root DNS also doesn't know the IP address of cis.poly.edu, but it notes that this name ends with the .edu. So the root DNS knows that this edu DNS server, the top level domain, it may knows. So the root DNS forward the query by itself. The root DNS doesn't send the response, but it forwards the query to the top level domain. This is called recursive. In the iterative approach, the root DNS it sends the response that I don't know the IP address of cs.poly, but you may ask this top level domain .edu DNS server for edu or all name that ends with the edu. But in the recursive approach, the root DNS itself forwards the query to .edu top level domain. And this edu also doesn't know the IP address cs.poly.edu, but it notes for that this DNS cs.umas is responsible for this query. So therefore it also forward the query to this one. When the query is received here, so here the IP address of cis.poly.edu is stored. So it respond, but it doesn't respond to the client, it responds to the top level domain from where the query is received. So one copy is stored here at the top level domain DNS, and one copy is sent to the path, to the reverse path, to the root level DNS. And the root level DNS also store one copy of the IP address of cis.poly.edu in its cache, and one copy is forwarded to the local DNS server to the reverse on the path. Okay. And the local DNS server, when it receives, so it also store one copy of the cis.poly.edu IP address, and one copy is forwarded to the user. This way is called recursive query, recursive resolution. Okay. So what is the advantage of recursive approach over the iterative approach? So let's discuss through an example. The advantage is that, for example, another host, this is another host, it also wants to get the IP address of cis.poly.edu. So when it queries the root DNS, so the root DNS already have in cache the IP address of cis.poly.edu. Why? Because when this query was returned on this path, so each top level domain, the root, the local DNS, they have stored one copy. And why this client is accessing the root DNS directly without local DNS? Because this host is maybe in home, in another home, and they don't run the local DNS server. So the local DNS server is not necessary. So if it access the root DNS, so the root DNS already have the in cache the IP address of cis.poly.edu. Because when this query was resolved and the response was sent, so each one, the top level domain, the root, and the local DNS, they have stored one copy of the IP address of this name. So the root DNS will immediately respond. So all these steps are skipped. So this saves the time for this client. Okay, so this is the advantage of recursive. So both recursive and iterative, they have their own advantages. So both are okay. Okay. So the DNS caching that I have explained to you, that once any name server is learned, it is cached and its caches mapping. That information is cached. For example, in this recursive, approach, when the IP address of this cs.pulley was sent to the top level domain, so the top level domain cache is one copy and forwards one copy to the root DNS. Similarly, the root DNS cache is the one copy of the cis.pulley.edu IP address and one copy is sent to the local DNS. Similarly, the local DNS also caches one copy. Okay, so in the iterative approach, when this local DNS server it receives the response from the root that for EDO, all the host name that ends with the EDO, the responsible DNS is this one. So it stores one copy, and when the another request, okay, when another request for the CUI.edu is received at the local DNS, so this local DNS knows that this host name it ends with the .edu, and for edu this top level domain is responsible because it is cached here. So this helps to speed up the DNS resolution. Okay. So the cache entries and the cache also have some timeout. The cache are not for infinite time. It disappears after some time. Okay, and the cache is maintained in the root DNS as well as in the top level domain. So you can find the what should be the cache timing, etc. All these things they are defined in the RFC for the DNS. Okay, and you know what is RFC? What does RFC mean? Okay. Now, how the DNS record is stored? Okay, the DNS record or information, they are stored in a special format which is called RR format. RR format means resource record format. In this resource record format, it has syntax 4 tuple: name, value, type and TTL. And their type is A. There are 4 types: A, NS, CNAME and MX. And each one has its own syntax and semantic. Okay. If type is A, for example here A, then it means that host name is the name and value is the IP address of the host name. For example, this is the RR. In this RR, A is type value is A. At the type, its value is A. So it means that this is the host name www.ibm.com and this value is the IP address of this ibm.com, and 60 is supposed time to live, 60 minutes, 60 seconds, suppose 60 hours. Okay, so this is one type. If type is A, then it means that this is the host name and the value is the IP address of this host name, for example this way. If type is NS, what does it mean? For example, type NS means the name is the name of the domain, for example foo.com, .edu, .yahoo.com, .com, etc. For example foo.com, and value is the DNS for this .com. For foo.com, its DNS is dnsfood.com. And type is NS and TTL is 60. Okay. Similarly, the host name, there can be aliases and they can be full name. For example, what is your full name? Okay. So my one of my friend, his full name is Sayyid Tamliq Ali Tanvi. It's a long name, but the people use short name. So remembering long name is difficult. So similarly, the host name, their full name is called canonical name, real name, and it can be very long. Okay, so normally the user they access by using alias, by using the short name alias. Okay, so the alias can be represented, for example, by this way. CNAME. CNAME means that this record shows this is the alias and this is the real name. So the real name is longer and the alias is shorter. So the user access through aliases. Okay, and 60 is the time to view. Similarly, on a web server on the same host, there can be web server, there can be mail server as both. So for this purpose, if there is a mail server, then MX's record is stored. Okay, so all the DNS, what is the IP address of a name? So these information, what is the DNS for this domain? So all these information, they are stored using the RR format. They are stored in the RR format. Okay. Now, what is the DNS protocol? Okay, the DNS protocol. As we have discussed, that DNS is a application layer protocol. It is a application layer protocol. So it also have a syntax and semantic. So the DNS, it has only one message format, because in the HTTP we have discussed there were two formats, HTTP request and HTTP response, their format. But here there is only one message type format. But the first value is identification. It is the identification of query and response. Okay, this is the identification. For example, it is a 16-bit value that identifies the query and response. For example, if a user sends a query with the identification number 6, so the response will also have the 6, because when the host receives a response, so it should know that this response is against which query. So for this purpose, the identification number is used. The flags, its value, there can be flag whether this message is query or reply. This message is a query or reply. Whether recursion is desired or not. If this flag is on, then the recursion is desired, that the host or the client wants to resolve the name using recursion. But it depends that whether the DNS server they support the recursive method or iterative. If they can support both methods and the client sends the recursion is desired, then the DNS will resolve the query by using recursive approach. But if the DNS doesn't support the recursive approach, then it will resolve using iterative approach. And similarly, the DNS can respond that whether the recursive method is supported or not supported. And whether the reply is, when the DNS reply is received, so whether the reply is received from authoritative or received from a cache. For example, you can see in this example, when this host sends the query for this CS pulley, so it was sent to the original DNS server where cis.pulley.edu was stored. Its IP address was stored, and the reply came from here. This is called authoritative DNS. So here the response came from the authoritative DNS, from the original server, DNS server, where its IP address is stored, hostname and IP address is stored. And for this query, for this host, when it sends the query, the request for cs.pulley.edu, so the query came from the root, from the cache, not from the authoritative DNS. Okay, so this distinguishing can be made by using this flag. The reply is authoritative. So if the response comes from the authoritative DNS, then this flag will be on. If the reply comes from another DNS server, for example from the root or top level domain, from a cache, from the local DNS server, so in this case the reply is authoritative, this flag will be off. So if this flag is off, then it means that the response is from a cache. The response is from a cache, not from the authoritative DNS. Okay. Similarly, there are fields. For example, you can see that how many number of questions are there, how many number of answers are there, resource record, how many number of authoritative resource records, and how many number of additional resource records. Okay, so the questions, they are placed here in the form of RR. The answers are placed here in the form of RR. The response from the authoritative, they are placed here in RR, and there are some additional information. They may be helpful information. Okay, now let's discuss an example. Up to now we have discussed what is DNS, how a name IP address can be found in the DNS hierarchy. But now we are going to discuss another perspective, that how you can insert record in the DNS hierarchy. Okay, so suppose that you have made a server, a web server, and the web server its name is networkethiopia.com. So first of all, you have to register it in the DNS registrar. For example, nowadays the DNS registrar is IK. So first you have to approach to DNS that I want to give my host this name, networkethiopia.com. So the DNS registrar will first confirm that whether this name is unique or not. If this name is already used, then they will say, okay, this name cannot be used. Why? Because it is already in use. So you should give some other name. If this name is suppose unique, this name is not already in use, so then the DNS registrar will say, okay, you can use it. Okay, but how you can use it? Let's discuss it. Suppose this is the DNS hierarchy already present. Okay, now you have built, you have constructed, you have a system host, and here networkethiopia.com web server is running, and you give this host a name, www.networkethiopia.com, and you confirm from DNS registrar that this name is unique. And this host, it also have IP address. This is IP address is 1.1.1, because when this host is connected to the internet, so if anyone wants to access this host, so they will access through IP address, not through name. But the user, they type the name, so the name should be first resolved into IP address. So this, how this information is inserted in the DNS record. If the user wants to find the IP address of networkethiopia.com, then how this is found? So we have to insert this record into DNS hierarchy. So how it is inserted? Let's discuss it further. Suppose this is the DNS server, authoritative DNS server. Its name is dns1.networkethiopia.com, and its IP address is 212.212.212.1, and this DNS server, it stores this information that networkethiopia.com, its IP address is 1.1. This information is stored here. So this server will be remain the authoritative. It will be present permanently here, and this system should also be accessed through internet. It should be always available 24/7, connected to the internet. Okay, so how you insert this information that networkethiopia.com IP address is 1.1? So you have to insert here. How you have to insert here? You have to insert in the resource record format, that www.networkethiopia.com, this is host name, its IP address is 1.1, and the type value will be A, and its time value is 60 seconds, suppose 60 hours. Okay, this information is, so this host, it will store this information in the DNS1 networkethiopia.com on this machine, and now this machine should be connected with the .com. Why? Because it ends with the .com, so it will be connected with the .com top level domain, and .com is already connected to the root DNS. So when it contacts the .com, so it should store some information, that if someone asks you for networkethiopia.com, then this networkethiopia.com IP address is stored with the DNS1 networkethiopia.com. So how this information is stored here at .com? So it will be stored like this way, that the first resource record, if anyone asks you for networkethiopia.com, then this information is stored with the DNS1 networkethiopia.com, this one, and its resource record is NS. NS means that for networkethiopia.com, its information can be found on this DNS. Okay, so, and this is the name. So what is the IP address of this DNS1? DNS1 networkethiopia.com, its IP address is 212.222.1a. That the first one, when a query comes to root DNS, it will forward to .com. When .com receives for networkethiopia.com, so networkethiopia.com will have this record. Therefore, networkethiopia.com DNS1 network.ethiopia.com, this is the DNS. But the query is always forwarded based on IP address. So what is its IP address? Network DNS1 networkethiopia.com IP address is 212.212.212.1. Okay, that's it. Now anyone over the internet, if they wants to access networkethiopia.com IP address, so they can contact the root DNS. Let's suppose, for example, this is a user. She wants to access www.networkethiopia.com IP address. So she wants to access this system. So first she typed this name, but the system can be accessed in the internet using IP address. So first she will find the networkethiopia.com through DNS. Okay, so what does it mean? She will send the query to root DNS, that I need the IP address of networkethiopia.com. Now the root DNS, it doesn't have the information, but it knows that this name ends with the .com. Okay, so for .com, this .com DNS is responsible. So the root will forward the query to .com DNS, because suppose it is using recursive approach. If it is not using recursive approach, then the root DNS will send the information that I don't have the information, but you can contact the .com. Then the user will contact the .com. But suppose we are using recursive approach, so the root is forwarding the query to the .com. Now on .com, this information is stored, that networkethiopia.com, its IP addresses can be found with the DNS1 networkethiopia.com, and DNS1 networkethiopia.com is stored at the IP address 212.212.212. So therefore .com will contact this one. So .com, it forwards the query to here, that please forward the IP address of www.networkethiopia.com, and it has stored that the IP address of networkethiopia.com is 1.1.1. It is stored in this resource record format. So it forwards this IP address information, this resource record, to the .com. So .com will store one copy, that www.networkethiopia.com, its IP address is 1.1.1. So it will be stored one copy, and it will forward to root DNS. The root DNS will also store one copy, and then the root DNS will forward to this user. So when this user receives this resource record, that networkethiopia.com, its IP address is 1.1.1, this one. So this user directly access this system. Okay, so this is the way how the resource record is inserted in the DNS. Okay, so I think it is clear to you. Okay, so we have discussed it through example. Okay, so how now think about, if there is no DNS, can internet work? Can you access internet? Yes, but by using IP address and port number. if one remembers it. But it is difficult to remember IP address and port number. Any one of you who remember the IP address of yahoo.com, facebook.com, google.com, now what? So if the DNS is stopped, then you cannot access the internet. You can access if you do remember the IP address and port number. Okay. So by this class is ends. So we have discussed the DNS protocol. Okay.